Good morning to everybody. This is Divyavani, working as assistant professor in CSE department in Institute of Aeronautical and Engineering College. So today we are going to discuss about deterministic finite automata. Right? This is also a part of the finite automata. In finite automata, we contains a different types of finite automatas. One is a finite automata with output and another one is finite automata without output. In finite automata with output, we contains two types. One is Mealy machine and another one is a Moore machine. Mealy machine and another one is Moore machine. We are coming to the finite automata without output. We contains three types: DFA, NFA and epsilon NFA. DFA is nothing but a deterministic finite automata. NFA is nothing but a non-deterministic finite automata, and epsilon NFA is nothing but epsilon on non-deterministic finite automata. So today we are going to discuss about this DFA, deterministic finite automata. Right? So what is a deterministic finite automata? It is the uniqueness of the computations. So already we have learned how the finite automata will be work, but this deterministic finite automata contains its own uniqueness. So what are that uniqueness is nothing but for there is only one path from the current state to the next state. For example, if you contains a input symbols called A comma B, right? If it contains an input symbols from input symbols A comma B, and if it contains a state called Q0, right? What is there? I have given only one path from the currents to the next state on every specific input symbol. That means how many input symbols that they have given to us, that should be only one input symbol should be there. So that means on Q0, on seeing A, it has to go to one state, and it on seeing B, it has to go to one state exactly once. That means all input transitions should be occurred only exactly once. That is the uniqueness of the deterministic finite automata. And it also does not accept the null moves. Here null moves is nothing but if I present in particular state called Q0, if I move from Q0 to Q1 without having any input symbol, on these transitions. So these type of states, we call it as a null states. Null states or null moves. Null moves or epsilon moves. Okay, this is the uniqueness. First point, we have to move on the current state to the next state by carrying any of the input symbol, and it has to be occurred input symbol only once, and it has to execute all the every specific input symbol. Every input symbol there should be transitions from one state to the another state, and it also does not contains null moves. Right? So this NFA, how this operates? If I pointer to the start state and reads the input string W, that means if I points to the start state, called Q0, right? How we represent the start state? By using a arrow mark with no source, right? Q0, and reads the input string called W from left to right and move the point according to the transition function. So if I moves to the Q1, we can read only one symbol at a time. If the next symbol of string W and the pointer is on the state P, move the pointer to the delta of P on A. That means if I want to see one more transitions, that means I have to move on seeing that particular any A input symbol, I have to move to the any other output state. Right? When the end of the input string is uncounted, then the pointer on the same state will be a final state. That means if the desired input has been occurred, then the particular state where you have reached, that particular state we call it as a final state. So here I have given an example to define how these DFA will be drawn. So, right, the first question is DFA with input symbols, what they have given, 0 and 1. What is the questions they have given? Accepts all strings starts with 1. Accepts all strings starts with 1. As soon as we see the question, first of all, we have to recognize what are the input symbols present in the question. So, what is the input symbols? They are denoted by using a sigma, right? 0, 1 are the input symbols. Right? Then next, based on the question, we need to write the language. So here, what is the question? Accepts all strings starts with 1. Accepts all strings starts with 1. Here we need to write the language. Here language is nothing but all possible strings which are derived from this particular questions. Starts with 1 means 1 I can take, 1 1 I can take, 1 0 I can take, and 1 0 1 and 1 1 1 and so on I can take. Any length of the string that starts with 1. That starts with 1. So I starts with Q0. So now, then after writing the language, we need to define whether the language is a finite language or not. So here we have a strings more than countable, so on. That means this particular language is a infinite language. Infinite language. So therefore, how to draw the transition diagram for this particular language? So what is a transition diagram? The transition diagram has to accept all the strings which are present in the language, as well as the transition diagram should also reject the strings which are not present in the language. So in that way we have to construct the transition diagram, right? So first I start with so if the language is infinite language, we have to take the smallest string. If the language is a finite language, we need to take the maximum length string. So here what is the smallest length string? 1. So I write the Q0 1. On seeing 1, I reaches the final state called Q1. Right? So is this a DFA? No, this is not DFA, because each and every should contains all the input symbols exactly once. So here I got the input symbol 1 on Q0, but I don't have a 0. So what is the question? All strings starts with 1. So here the string will be starts with 1. What are the possibilities of keeping 0? If I keep loop, I can keep, or else I can send it to the next state, or else I can send it to the dead state. So these are the 3 possibilities. First possibility, second possibility, and third possibility, sending it to the dead state. So let us check one by one and why we are not keeping that string as a loop. So first, if I keep the loop here, what it will happen? I can also execute a strings called 0 1. 0 1. It reaches the final states. So that is why this first option is ruled out. Right? So next one, sending it to the next state, Q0 to Q1. In this case, I can also execute a string called 0 that is not present in my language. So therefore, the second option is also ruled out. Right? And the third option is sending it to the dead state. So we don't have any other option. So we are just sending it to the dead state. So dead state will be represented like this. So Q0 work is done. Q naught contains a input symbol 1 and input symbol 0. The work of the Q naught is done. Then what about the Q1? So here after the string should starts with 1. After that I can contains any number of zeros and any number of ones. Right? So therefore I can keep a loop here which contains 0 and 1. I can keep the loop over there which contains 0 and 1. So this is how you draw the DFA. This is how we draw the DFA. Right. So how this DFA is defined. Next, DFA is defined. How the formal definition of the DFA. As I have told in the previous classes, if for the finite automata, all the finite automatas are defined by using the specific 5-tuple notations. Those are M is equals to Q sigma delta Q naught and F. These are common for all the finite automatas. But what is the difference means it will be differ at the transition functions. So first of all let us learn what is this Q. Q is a finite set of states and sigma is finite set of input symbols and delta is transitions functions and Q naught is initial state and F is a final state. So transitions functions can be defined as in this. What is the difference between finite automata to DFA is in the finite automata or in the DFA V contains delta is equals to Q cross sigma tends to Q. For example, for the same previous drawn diagram, let us draw the transition functions. Right. So what is the diagram for the previous one? Q naught on 1, it reaches Q1 final state. If I say 0, I have to go to dead state. Yes. So this is your transition diagram in the previous slide. Okay. For these, let us draw the transition functions. That is, what is the transition functions here? Delta is equals to Q cross sigma tends to Q. So here what is Q? Q is nothing but a finite set of states. What are the set of states present in this DFA transition diagram? Q naught, Q1 and Q2 are the states cross and sigma. What is sigma? Sigma is nothing but input symbols. What are the input symbols that we contain? 0 and 1. So if I perform the cross operations between these two, what are the outcomes that I will get? Q naught on 0, right? Q naught on 1, right? Q naught on, Q1 on 0, Q1 on 0, Q1 on 1, Q2 on 0, Q2 on 1. Right? Then after again tends to what it is there? Q again. What is a Q here? Q is nothing but set of states. What are the states? Q naught, Q1 and Q2 are the states. So Q naught on 0, where it is moving? So based on the diagram, Q naught on 0, it is moving to Q2. It is moving to Q2 here. Right? Q naught on 0, it is moving to Q2. Right? Q naught on 1, where it is moving? Q1. Q1 it is moving. Q naught on 1, Q1 it is moving. Next, Q1 on 0, it is Q1 on 0, it went to the self loop. So, Q1. Q1 on 1 on the self loop again. Q2 on 0, again self loop. Q2 on 1, again self loop. So this is how we represent the transition functions for any DFA, or else this is one method of representing the transition functions, and another one is second method, delta of Q naught on 0, transition function of Q naught on 0 it goes to Q1, Q2. Q naught on 0, it goes to Q2. Delta of Q naught on 1, it goes to Q1. Delta of Q1 on 0, it goes to Q1. Delta of Q1 on 1, it goes to Q1. And delta of Q2 on 0, it goes to Q2. And delta of Q2 on 1, it goes to Q2 again. So this is how the transition functions will be moving. This is one type of transition functions, and these are the another type of transition functions we used to mention. So this is the formal definitions of the DFA. Then we have two types of acceptance in of the any of the finite automata. One is a language acceptance, another one is called a string acceptance. So what is a language acceptance? So language acceptance is nothing but if all the strings in the language are accepted and all the strings not present in the accepted are rejected, then that particular language is accepted. So here, so if I take a example like string length 2, string length 2 over A comma B. So on A comma B, I am taking a string length of 2. So for that, how to draw the DFA? I start with the Q naught string length. First of all, write down the language. String length 2 means it only accepts AA, AB, BA and BB. Right. So this is a infinite language. Finite language. What is the meaning of finite language? The language which can be countable. Right? If I take any of the string. So in these finite language, I need to take the maximum length string. But here, whatever the strings that I was having, it is a only 2 length string. Right? So I can take any of the strings. So if I take a string called AA, Q naught on A, right, it reaches the Q1, and Q1 on A, it reaches the state called Q2 as a final state. Right? Here, and I also need to accept AB, BA and BB. Right? AA. So next, first check the Q naught on A. Where should I keep the B on the Q naught? Either I can keep the B on here, self loop. If I keep the B in the self loop, I can also execute a string called BAA. B 2 times AA. Yes, right? Or else BAA is also get accepted. The 3 length string and 4 length strings are not accepted. So that is the reason why we should not keep the B on a self loop. So this is a rejected. Or else can I send it to the dead state? Sorry, sending it to the dead state. So if I send a dead state, if I want to execute a string called BA, I can't able to execute. So the dead state is also get rejected. So that the only option that I am having is sending it to the next state with the B. So therefore I can execute AA. Yes. I can execute BA. Yes. Okay. Now next. Q naught work is done. It contains a 2 input symbol with the 2 transitions. Done. Next Q1. Q1 is having a input symbol A with the 1 transition and it should contains a B. Either what are the possibilities? I can keep here B or else send here B or else I send it to the dead state. Right? So if I keep the loop there, I can able to execute a string called A. I can execute a string called A, B, A. Right? So this, what is the string length of this? The string length of this one is a 3 length string. So this is not accepted. So loop is rolled out. Right? Or else sending to the dead state. So if I send the dead state, what it happens? A string called AB cannot be executed. So I should not send it to the dead state. So what is the only leftover thing? Sending it to the back. sending it to the next state with the B. So therefore I executed AB, BB, final state. Right? So this is called the language accept. The finite automata, first of all, what is? All the strings in the languages are accepted. Yes, all the strings. What are the strings? AA, AB, BA and BB. All the strings in the languages get accepted. And the second point is the string should not accept the language which are not present in the language. The string should not accept the finite automata should not accept the strings which are not present in the language. For if I take a string called AB, AB, what is the string length of this? The string length is equals to 4. That it should not be accepted in this particular automata. Right? A, B. Right? After AB, I don't have any source to reach the next A. So before that, let us question itself. The languages have been all accepted. Is this a DFA? No, this is not a DFA because Q0 is having a two input symbols A and B. Q1 is having a two input symbols A and B. Then what about the Q2? Then what about the Q2? Q2 also should contains a and B. So if I keep a loop here and if I give the A and B, what it executes is executes a string length more than 2. So that's why it should be ruled out. So whatever if I take, it will execute a string length of more than 2. But the question is a string length is equals to 2. The string length is equals to 2. So therefore, after this, whatever I get A and B, I just send it to the dead state. Whatever I get, I just simply send it to the dead state. So this is the DFA for the string length of 2. So now check any string called A, B, A, B. So here A from Q0, it reaches the Q1 and B, on seeing B, it reaches the Q2. On seeing A again, it reaches the Q3. And on seeing B, it reaches the Q3. So that means the string which is more than 3, it reaches the dead state and die there itself. It cannot come back to the final state and get executed. Right? Any length string we can take. It will not get executed except the string length of 2. So this type of language acceptance is called as a language acceptance. Okay. The next one is called a string acceptance. So here string means any string. For example, if I take a string called AB, AB, right? It has to start from the initial state and should reaches the final state, then the string is called a acceptance string. Right? So if I take a string, if I take a finite automata, string length is less than or equals to 2. Less than or equals to 2 means it should accept 0 length string, it should accept 1 length string, and it also should accept 2 length string. So, okay. So, if I take a string length called finite automata on Q0, I need to execute a 0 length string. Write down the language. 0 length string means it should accept the epsilon. Right? 0 length string will be represented by epsilon. 1 length string over an input A comma B. So 1 length string means it should execute A and also it should execute B. If the string length is 2, it should execute AA, it should execute AB, it should execute BA and it should execute BB. Right? So these are the strings that it has to get executed. So Q0. So how to make the execution of this epsilon? In order to execute the epsilon or a 0 length string, the initial state will become a final state. The initial state will become the final state. Okay, next one, or one length string. On seeing A, I reaches the Q1. Q1 also will be my final state in order to accept the length string 1, string length 1, right? And also B also I should get executed. So B also one length string. So I just send it to the Q1. Next, in order to accept the two length string, I reaches the another state called Q2, right? And make it also as a final state. After the two length string, none of the string should get executed. So I simply send all A's and B's to a dead state. Okay, for this, if I take any string called AB, how this state will be get executed? So AB, if I take, I starts with the Q naught. On seeing A, I reaches the state called Q1. On seeing B, I reaches a state called Q2. On seeing A again, I reaches a state called Q3, and on seeing B again, I reaches a state called Q3. So the Q naught I starts with initial states and it ends with the Q3 state, which is not a final state. So therefore this string is not accepted. So if I take a string called AB, if I take a string called AB, I start with Q naught. On seeing A, I reaches the Q1. On seeing B, I reaches the Q2. That means this from starts with the initial state, I reaches a state called Q2, which is a final state. Therefore, this particular string will be get accepted. Okay, next we will discuss some more examples on the DFA. Right? The first question is, construct the DFA which accept the string 0 over an input symbols 0, 1. Here I am giving only one string. What is the input symbols? I need to define first. I need to check 0 and 1 are the input symbols, and based on the questions which accept the string 0. That means they have given a language only 0 acceptance, right? Only 0. So how to get accept that particular string 0? That means I starts with the Q naught, right? As I have told you that how to make the 0 or a epsilon string accepted, right? String 0, right? So that means I starts with Q naught. On seeing 0, I reaches the final state Q1. So I should execute only one single string, that is 0. Q naught, or in DFA, Q naught also should contains input transitions for the 1. So if I get 1, where I should send? I should send simply to the dead state on 1. And after 0, if I get any input symbol 0 or 1, I just simply send it to the dead state. So the finite automata, the DFA, deterministic finite automata of this DFA accepts only a single string called 0. Only a single string called 0. The next question is, construct the DFA which accepts the strings 0, 0 over an input symbols 0, 1. So here my task is first recognizing the input symbols 0 and 1, and language, need to write the language based on the question. So what is the question? Which accepts the string 0, 0. The only one string that it has to be get accepted. What is the string? 0, 0. Right? Always I starts with my initial state called Q naught. On seeing 0, I reaches the state called Q1. On seeing 0 again, I reaches the state called Q2, and I reaches the final state. That means I need to accept this 0, 0 length strings. So in between, Q naught should contains one transitions. So if I see the 1, I should go to the dead state. Right? If I see the Q1 on 1, also I should go to the dead state. After 0, 0 length string, if I see the string length, any string length 0 or 1, I should go to the dead state. So let us check. If I take a string length 1, 0, 1, 0, I starts with the Q0. On seeing 0, I reaches the Q1. On seeing 1, I reaches the Q3, and on Q3 on seeing 0, I reaches the Q3. So here it doesn't reaches the final stage. So therefore this string is not accepted. So if I check a string called 0, 0, I starts with Q0. On seeing 0, I reaches the Q1, and on seeing 0, I reaches the Q2, which is a final state. So therefore, this particular finite automata accepts only a single string called 0, 0, which is of string length 2. Right? Now, this is another question which accepts the string length of 2. Right? Again, so first check the input symbols 0 and 1. Then write down the language. So language which accepts the string called 0, 1 only, single string 0, 1. Right? So I starts with the Q0. On seeing 0, I reaches the Q1, and on 1, I reaches the Q2, which is a final state. And next, now Q0 is having a input transition for 0. It also should contains a input transition for 1. So it reaches to the dead state. If I get any string starts with 1 here, I reaches to the dead state. Here also, in between 0 and 1, if I get any input symbol, right, I should reaches to the dead state. And after 0, 1, I should not contains any strings which contains 0 and 1. So I simply send it to the dead state. So this is how you need to draw the DFA diagram. So this one is called a string length of 2, that already we have discussed over here. This is a string length 2. Right? The next one is string length is greater than or equals to, that already we have discussed over here. This is called a string length greater than or equals to 2. Right? And next one is string length is greater than or equals to 2. That first construct the DFA which accept the string length. We always write the string length by using mod W. Right? Where string length is greater than or equals to 2. That means what are the possible string length? Right? 2, 3, 4 and so on. That means it is greater than or equals to 2. First recognize what are the input symbols. The input symbols are 0 and 1. And next write down the language. The language should accept a string length greater than or equals to 2. So first write down the string length which accepts 2. AA, AB, BA, BB. Right? Next 3 length string AAA, ABA, BAB, BBB and so on. Any length string till infinity. Greater than or equals to means 2 and more than 2 length string. So how to construct this finite transition diagram for this, or a deterministic finite automata. So as this language is a infinite language, we should take the smallest string present in this language. So if I take a smallest string called AA, I just read the basic structure of the deterministic finite automata. A, and it reaches the final state. After final state, I should fill all the rules of this particular DFA, deterministic finite automata. right? So here Q naught contains A. What if in case if I get a B? Is that accepted? If I keep a loop here, can I execute a string called BA? BA. It does not reaches the final state. So therefore, can I send it to the dead state? No. I also have a strings which starts with B. So I should not send it to the dead state. What is a possible? I send it to the next state to the Q1. And next Q1. Q1 on A we have. Right? In the same way, if I contains a string called B, what it happens if I keep a loop here? Can I execute a string called AB? No, I can't. A it reaches, on B it stays on the Q1 itself. So I can't give the loop over here. So I have a possibility only sending it to the next state. So therefore till now my two length string will get accepted. A can be accepted, AB is accepted, BA is accepted and BB is also accepted. Till now my two length string got accepted. But what about the 2 and above string should be get accepted? So in order to get accepted 2 and above string, we just simply keep the loop over here A comma B. Loop over here A comma B. That means it accepts the string lengths which are equals to 2 and greater than 2. So if I take a string called AB, AB. I starts with Q naught. On seeing A, I reaches the string Q1. On seeing B, I reaches the Q2. On Q2 on A, I reaches the Q2 again. On seeing B again, I reaches the Q2. Here I reaches from the initial state to the final state. So therefore AB which is of a string length of 4 is also get executed. And also we have to check whether this finite automata wrong by taking the strings which are not present in the language. Is a string called A is present in the language? No, it is not present. So if I take a string called A, I starts with the Q naught and seeing A, I reaches the Q1. Q1 which is not a final state. So therefore a string length is not get accepted. Right? So this is the how we draw the deterministic finite automata for the string length greater than or equals to 2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.